Hello, we are Group 8, and today we are presenting the MXET 300 project proposal for the beverage bot. Our project focuses on designing an autonomous robot capable of retrieving a beverage and delivering it to the user, and then disposing of the empty container once it is finished. First, we will go over the basic functionality of our system. The robot begins at a designated home base where the beverages are going to be stored in a cooler. Upon receiving a command, it will go and retrieve a drink and then navigate back to the user while avoiding obstacles. After delivering the beverage, the robot will then later get a command to then pick up the trash when the drink is going to be finished, returning back to the user and picking up the empty container and disposing of it into the trash can. To achieve this, we will have to first design a cascading lift and a robotic claw, then assemble all of the hardware and sensors onto the system, and then create a structured home base which can implement as our cooler. Finally, we're going to implement the software for the navigation control.
So the general idea of how we're going to accomplish this is we're going to have a cascade lift to move the beverage up and down and raise it to you. And then we're going to have a claw to grab onto the can or bottle or whatever it is. And these will be controlled through DC motors. So one for the claw and one for the lift. And these will also have their own coder setups as well. And at the top of that cascade lift is the camera that we'll be using for our computer vision implementation. So that's how we're going to identify the correct beverages. And then we have the LiDAR on the scuttle for navigation purposes. And then we're leaving the motors on the wheels set up as they are right now. And as for the project roadmap, so the phase one will be the hardware, actually building the new additions to the beverage bot. And this will start by creating a list of parts that we'll need. So any additional DC motors or anything else we'll need for the cascade lift, like belts. And then as well as designing the cascade lift and designing the robot claw and assembling these parts onto the scuttle frame. And then the goal is just to get everything assembled and then keep iterating and fixing whatever issues you run into.
For the software phase, we'll use speech-to-text for the user drink selection. LiDAR will be used for obstacle avoidance. Localization and path planning will be done with computer vision. April tags will be utilized for visual markers at key points, such as where the drinks are stored and where to deliver them. Motor control logic will be written for the claw and cascade lift to grab and raise the can. The final goal is a fully autonomous robot that can hear a command, retrieve and deliver the drink, and finally take the can for disposal.
Our project timeline is structured into clear weekly milestones. By the first week, we would have developed a complete list of required materials and components and then begin acquiring them all. By the second week, we would have finalized designs for the robotic claw and the cascading lift. Then, by the third week, we would have assembled and tested all the components and made any necessary adjustments. Then finally, by the 28th, we would have then completed, demonstrated, and presented the beverage robot.
We've organized our timeline into two main tracks, hardware and software. On the hardware side, sensor integration is our first priority since it allows software to start developing early. So we have this scheduled to be completed by April 10th. Next, we have our claw mechanisms, and it requires multiple design iterations. So that will begin shortly after and wrap up around April 13th. And finally, we have we have to complete the lift system, which integrates both the claw and the sensors. And this phase will run into week 3, leaving some time for refinement and optimization. On the software side, we will start with the microphone and sound controls as they're most straightforward and easiest to do. Next, LiDAR and PID controls are developed together for obstacle detection and motion control. And the final, most time-intensive task is path planning, which handles full system automation from navigation to task execution and continues through weeks 2 and 3. We've included a buffer period in red to account for delays to ensure that we stay on track. So thank you for your time. Do you have any questions?